All right, now we are going to look at some word problems, some real life scenarios on exponential decay, and talk about how to go through and solve them. Okay, so this problem says your car depreciates at 13.5% per year. If you bought a car for $23,000, how much will it be worth after 5 years? So first, let's write our function. Remember, it's going to be y equals a times b to the x. A is our initial amount. It's our starting point, which in this case is 23,000. B, when we have that percent, we are going to do 1 minus the rate. Even though there's a decimal here, I still need to change it to a decimal by moving it 2 spots to the left. So I'm going to do 1 minus 0.135. Okay, that's how I'm going to get my B here. So 1 minus 0.135 gives me 0.865. So that is my B. And then it's going to be to the x, where in this case, x is each year because it's 13.5% per year. Okay, so this is our function. Now we need to answer the question, how much will it be worth after 5 years? So I'm going to take my function, and in place of x, I'm going to put the 5. So remember to do order of operations first. So you're going to do 0.865 to the 5th power. And this gives us a pretty long decimal, so we are going to have to round. So I'll just say it's about 0.48. And then I'm going to multiply the number that I got when I did 0.865 to the x times 23,000. And because this is money, I'm going to round to the nearest cent. After 5 years, the car is worth $38.03. And again, how I did that, x is each year, so if I want 5 years, I plug that in for x. So I did 0.865 to the 5th, which gave us about 0.48. And I'm going to multiply that by 23,000, which is where this answer came from. So this next problem says each year the local country club sponsors a tennis tournament. Players start with 128 participants. During each round, half of the players are eliminated. How many players are left after 5 rounds? So again, let's write our function. Okay, A is our starting point. We start with 128 participants. B is our growth rate, which in this case is decaying, so it's going to be between 0 and 1. But I don't see a percent here. But here is what tells us. Half of the players are eliminated. So I'm going to put in a half here. It's kind of like in the other problems for growth, when we had doubled or tripled, we would just put 2 or 3. When something is being halved, I write just a half. Okay, so x in this case is going to be each round, because after each round is when half the players go. So x is each round. So here's my function. And now for x, I'm going to plug in 5. So I'm going to do 128, 1 half to the 5th. So now I'm going to go and do 0.5, which is the same as a half to the 5th power. And that gives me 128 times 0.03125. Multiply that by 128, and we get there are 4 players left after 5 rounds. This last question. The pesticide DDT is widely used in the United States until its ban in 1972. DDT is toxic to a wide range of animals and aquatic life and is suspected to cause cancer in humans. The half-life of DDT is 15 years. Half-life is the amount of time it takes for half of the amount of substance to decay. So essentially what half-life means, or what it is that in that amount of time, how much we have is decreased by half. So you can see why this is so bad, the DDT, because if its half-life is 15 years, every 15 years, the amount that's in the air, in the atmosphere, increases by half. 15 years is a very long time. And because it's just cutting by half, it is getting exponentially smaller, but it's doing so in a very long period of time. It's doing it every 15 years, and it's never going to completely run out because it's just going to half and keep getting smaller and smaller and smaller, but it's never going to actually hit 0. Okay, so let's ignore this question for now, and let's just use this to write our function. Okay, so I don't know what our a is yet because it doesn't tell me. It tells me down here, but I'm ignoring that for now. Half-life would be half to the x. In this case, x is every 15 years. So once 15 years has passed, our x would be 1. Once 30 years has passed, which is 2 sets of 15, our x would be 2. That is our time interval, is every 15 years. So if I go here, my a is 500 because it wants to know how much is left after 60 years if 500 milligrams of DDT is released. So here would be our function. Now, I'm not going to plug in 60 for x because x is not every year. X is every 15 years. So it takes, if I do 60 divided by 15, we get 4. There are 4 sets of 15 years in 60. Okay, because 15 plus 15 plus 15 plus 15 would give us 60. Okay, that is why I have 4, because our x is every 15 years. So now I would do 0.5 divided by 4, which would give me 0.0625. And I'm going to multiply that by 500. 31.25 milligrams. That's why this is so dangerous, because there has been 60 years that have passed, and we are not totally out of DDT in the environment if that's how much is released. There is still 31 milligrams, and it's going to take 15 more years for that to cut in half, and it's going to take 15 more years after that to cut in half. Okay, so that is what half-life is. Email me if you have any questions.